Hi, everybody. Welcome to our YouTube live show. Right. So today we're gonna have our tea time data talk about enhancing smart manufacturing in the age of industry of 4WRD. Right. So of course, today's session will be the first of the year. So thank you everybody for supporting us. All right. So without further ado, okay, my name is Hank and I'm from Quandetics Academy. And of course, today we will have our honor speaker, Mr. Hakimi Nasir from NA Arbor Consulting Solution. All right, so let us welcome Sir onto the stage. Hello, Mr. Hakimi. Can you hear me?
Hello. Can you guys hear me?
Hello. Yeah, can hear you. Yeah.
Okay. All right. Good. Good morning, everybody. I'm Hakimi. Nice to meet you guys. Thank you, Hang. I guess are we starting now, or everybody has their tea, or how, Hang?
Well, it's a tea time data, right? Yeah, so I'm actually having my cup of tea here for my
Okay.
breakfast, lah. Huh?
So I guess I could start, right? Okay.
Yeah.
First of all, thank you very much, everybody, for deciding to spend the next 1 hour with Hang and myself. And actually, in the background, you might not see it is Zamina, the Insta famous lady from Quandatics. Thanks to Zamina also for facilitating this. Okay, so what we're gonna talk about today is basically using IR 4.0 disruptive technologies in managing your quality. Okay, I know that in the slide that Heng showed just now, there was a topic on safety, but yesterday when I was looking at how much information that could be shared in this 1 hour, I just dropped that safety and let's just talk about quality. Even though if you want, there would be bits and pieces here and there about safety where I would touch. Okay, but I would be happy to take your questions on safety too. All right. Okay. So what we are going to be talking about today. Okay. Again, Heng reminded me that this would be a very casual session. So let's keep it that way. Okay.
Yeah.
Yeah. All right. So let's just try to have fun while we are going and talking about this. But because of such a short time and so much information that we want to talk about, maybe we could uh, keep our questions till the end of the session, and I would attend to your questions if you have any. All right. So let's look at what we are gonna be talking about today. All right, there are a lot of information, but I think eight is enough. Okay, we are gonna revisit what quality means and what process is. Okay, then we are gonna quickly also revisit the various technologies within Industry Forward that we have available at our fingertips now that we could use, right? Then knowing what quality is and knowing what the technologies are available out there, then we'll go through the topic of how do we use this technology to disrupt the way we manage our quality. That's going to be a topic number three. Right. Then we'll move to number four. When we talk about using technology, all we are talking about actually is just managing this data. There are too much data out there in the factory that we have to manage. And actually, what we are looking at is just looking at those data, right? Then we'll go to the fifth topic, which is once we know what to do in our own factory, we don't want to stop there, right? We want to make sure that everybody in the supply, in the value chain, would be doing the same thing. So not just us, not just your factory. Now you want your value chain on the supply side also have this kind of digitalization on your customer side also. Then we are talking about hyper digitalization all around in the value chain. Okay, number six. So outside a subtopic to a smart factory is always the maintenance of our asset and equipment, right? That's a big pain, one of the big pain of factories. We'll touch like at least one slide on that. Then I'm gonna talk about topic number 7, managing change in your factory or in your operations, because a lot of times there are a lot of risks that come with change. No matter how small the change that you are trying to make in your factory, believe me, it will have some impact on quality or even safety. All right. Then I would close this discussion or tea talk with, so now we, with all these bits and pieces that we know from this session, so where do we go from here? If you decide on, I want to, get more information about this, I want to jump into digitalization, what do I do? What do I need to know? All right. Okay. Um, Before I go further, let's. I would just would like to introduce myself. You might be wondering why I am here talking to you, and what makes me the authority. Like, no, I'm not the authority in talking about neither the technology nor safety and quality. Just because I'm old. All right, I'm old. I have been working. I have been in the industry for 26 years. I have dealt with a lot kind of people, a lot types of organizations worldwide. Name it from Japan, China to the West, United States. Okay, I have been around, all right? Like the Malay idioms go, hey, I have eaten a lot of salt, okay? So I just want to share this information and this knowledge with you, along with the experiences. In terms of education, I started out in MRSM in Kota Baru. Then I flew to Bloomington, Indiana, get another year of high school in Bloomington North. Okay. Then there, I applied. I wanted to do mechanical engineering, so I applied to like 10 universities in the US, and I ended up in Michigan, Ann Arbor, and I graduated in mechanical engineering in 95. All right. In terms of my professional life, I started out in Michigan at a small factory, Irvin Product Development Center. My first job was to automate the quality control process. So I created and designed a machine to take samples from the production. I just do a lot. I did a lot of welding and cutting. I mean the hardware, also software. Right, I was using Allen Bradley PLC and some pneumatic circuit to build a machine. So that was my first experience. Then I came back to Malaysia and worked for Motorola, where I got my Six Sigma. Worked with Seagate and Western Digital. Then I went to Korea for a few years. I worked for a Korean company. Then I came back and totally changed my field, jumped into oil and gas. All right. I left my professional career deep in the MCO in 2020. So ever since, I've been just aloofing myself in this small village in Negeri Sembilan. All right. So I'm calling from Labu today in my kebun. Okay, so that's a quick brief about myself. Okay, so let's jump right into the action. Okay, I'm not really sure how about the demographics of you guys today, but I think it would be really good for me to just touch base or revisit about the Industrial Revolution. As you guys have known, okay, we are at the fourth Industrial Revolution. A lot of people actually have been pushing for Industrial Revolution 5, or actually the fifth Industrial Revolution. And this has been going on since as early as 2020. So we might be in the fifth Industrial Revolution already, but let's not worry about fourth or fifth, okay? Let's look at up to the fourth Industrial Revolution, which actually officially the fourth industrial revolution was agreed on in sometime in Germany back in 2011. Right, so that was what, 11 years ago, right? So if you look at the progress, okay, from the first industrial revolution back in the 70s, okay, what I want to draw your attention It's not on the detail of that revolutions, but on the time frame, the time it takes to the next revolution. If you look at the first industrial revolution, right, to the second revolution, it took more than 100 years, okay, 116 years, okay, moving from a mechanized production to electricity, right? So that took 116 years. Then if you look at the second industrial revolution to the third, it takes just a little less than 100 years. And from the third revolution to the fourth revolution took only what, 42 years. Okay, you know where I'm going. I mean, the revolution is coming at a faster pace now. So from the fourth revolution to the fifth revolution, that people are saying, hey, we are in the fifth revolution now, right? So it's only like 9 years now. So just imagine from the fifth revolution to the sixth or seventh, it might take only 2 years or months in the future, right? That's because technology is compounding. With the current technology that we have, things are moving at a very fast pace. So the question is whether be, we could pace ourselves with the advancements of not technology or not. Because if we don't, then we might be left behind. Things might not be too good for our company, our factory, right? Okay. So before even I go and talk about quality and the technology, let's spend a few minutes looking at the pain points of the industry. Okay, um, I'm not gonna go too much in this, but I just want us to realize and to be aware of what the pain points are. Especially for the factory owners. Okay, we are not going to be able to solve this with what we are going to be talking about today, all of it, but I would like to draw your attention to a few of these pain points that we would definitely be able to solve with technology and with a very good quality management. All right. The first one is the analog data. All right. Analog data. You have things in hard copies, right? So that's a no-no in this age, right? Um, Asset failure. We're going to touch that when we talk about maintenance, predictive maintenance. Now we talk about productive maintenance, and then pain point like reactive system. All right, reactive means that we wait until things has occurred, undesired event occurred, and then we take actions. That is bad. I mean, things happen, damage has done. Even if you take action, it's not going to be that meaningful anymore, right? So we want to be proactive. So what we're going to be talking about would try to solve these pain points too. Okay, labor intensive. With technology, we could reduce labor, reduce with machines. I know there are pros and cons about that, but technology could really reduce our dependency on labor. All right. Um, the other pain points is lack of data driven decisions, right? Just because imagine if you're in a factory, data are being churned out every milliseconds, right? Especially if you have hundreds of machines, one machine is giving you data every milliseconds. Imagine the amount of data that you need to look at, and a lot of times with manual processes, you are depending on your engineers or technicians to review and look at data and make decisions, right? And believe me, I've gone through that age, and you don't have time to look at all the data. So your decisions might be based on some amount of data, but not all. So you might not be making a very sound decision based on data. All right. I guess okay. The other pain that we might be able to solve with this technology and good quality management is the one size fits all mentality or setup, right? Now, if I am a factory, if I want to produce, say, like a cup like this, right? Then I would just produce, like, say, 100,000 pieces of this cup every day. I don't care what you want, but you have to buy it in this form because this is all what I'm producing. But with technology and proper quality management, I could go lot of one. All right, not one size fits all, but lot of one, meaning that if you want this cup to be, painted in yellow, then my production will go to do that for you. One yellow coming out, one blue coming out, just when you need it. Okay, that is the power of technology. Okay, of course, we're not going to be talking about cups. We're talking about maybe a more complex product, like cars and other machines, right? Okay, so enough with the pain points. Let's get to business now. Um, so what is a factory? Okay, before I jump into quality, what is a factory? I'm not sure the demographic of you guys, whether you guys from the factory or from service sector or whatever, but a factory, no matter how small you are or no matter how big you are, if you are a very small, say, kilang kicap, running everything manual, or even you are as good as, say, Western Digital in Batu Kawan. If you read the news, they are one of the leaders in digitalization and smart factory, right? So they might have hundreds of machines being managed, being ran by the cyber physical system, right? So no matter who you are, how big your factory is, this is basically what's going on in your factory. Okay, so let's look at this just to make sure that our minds are on the right scope now. Okay, so in a factory, if we look at the level of action, okay, we have 5 levels of activity or action. If you look at on the right side of the slide, those numbers, those represent the levels, okay, of actions or activities in a factory. Okay, look at the lowest one, level 0. Those are the actual production. If you are using operators running your product, these operators are doing job, right? That is the actual production in action. I put it at level 0. Okay, I cannot even call it level 1. It's the best basis. It's ground zero. All right, then if you move up from that level, we are talking about anything that trying to get data now from that process. Okay, we could have a sensor, right? And we from this data we could manipulate that data to react to any change or any needs from the production floor. If you don't have any automation, any gadget, any device whatsoever, meaning that this would be done by somebody, right? A technician or a supervisor might be standing there looking, okay, what's the problem? So a human becomes that next level, that sensor, right? Okay, so if you go further up now, we are talking a system to monitor and to supervise what's going on in that production floor. All right, in good companies with a lot of money, they might have what we call SCADA. Okay, a SCADA is a supervisory uh, um, um, which data will come in, and then you make decisions on what you need to do. Okay, it's an interface for supervision um, uh, on your production floor. All right, it's supervisory control and data acquisition. All right, so that is, I would lump everything of this level 0, 1, 2, 3 into one level where the operations is going on in your production floor. Then we move out to the next um, group of activities, which I would call as manufacturing operations. Now, management, right? The management of the operation. And in terms of the activities, now I would call it level three, all right, where usually good companies would have its manufacturing execution system, MES. Okay, this is where the production scheduling is being done, the quality assurance is being done, the safety assurance, right? This is ensuring that you have everything you need to make sure that you produce the right products, meeting and comply to the standards that you subscribe to, right? Okay, then if you go further up, the highest level activity in a factory would be where the business is being planned, right? And logistics, right? This is where your business, your activity starts actually and end. All right. Just imagine, how would a factory work? Okay, I receive, I do business development, I do sales, right? Then I would get order from the customer. This is the level where you get the order, and then you would be pushing it down. You would be running your scheduling, right? What do you want to build, how many, for whom, right? Your logistics. Once it's done, how would you manage your logistics to get your products to the customers? So this is the highest level, and usually good companies with deep pockets would have ERP, okay, enterprise resource planning, and this could cost easily. I think the cheapest would be maybe what, 3 million ringgit, right? So a small companies might not have SAP or this ERP software. They might be running manual, but it's fine. It's some sort of an ERP. So when we talk about the smart factory and how quality would be managed in our next slides, then this is the thing that I want you to remember. Okay, this level. Okay. Okay, I need to move on quickly now. All right. So what I'm telling you now is that in everything that you want to do, no matter what factory you are, what products you do, you need to always start with a proper quality planning. Okay, what you need to do is just to, and I break it down for you, all right, in simple steps. Okay, before you even run your business, or before you even run your product, remember this is being done on the highest level of the levels that we talk about just now, right? The first thing is you need to identify your stakeholders, right? The customer, right? Once you know the customer, then it's easy. Okay, what do they want, right? What do they expect from your product, right? Then knowing your customers and knowing what they want, then you would go and determine what is the feature of your product. If they want a cup, what kind of cup do they want? How big is it? The feature, right? Because only from that feature of the product, then you could decide on the goals of that feature. You want to do this in, what, the color, the dimensions, whatever things, right, of the product. Then once you know what the product is, then only could you design your process, right? So what is your process feature? Then you go to your process feature goals. I mean, if I need you need to use these tools, and yeah, that machine will have to produce this might be stamp, right? Or lathe machining, right? So what's the feature of the process, right? Then once you know the process to build your product, then you want to know how to control it. Now you get to the quality, really deep into quality control, right? How you control this process to consistently give you that product, right? Once you know the customer, the product, and the process, now you go into determining, hey, to get this done, what kind of material do I need? From whom? From which supplier? Right? What is my specification for the incoming material, and from whom would I be buying? Once you know your material, then you know who the suppliers are, and then you go a step further. how do you control or how do you manage your supplier to give you consistent quality, right? Because remember, input plus your process equals output. If you have a good input, you have a good process, you don't really need to look at the output anymore, right? That is quality management. And you need to always start with a good quality planning. Okay, this is where the cost of quality is being set. Okay, all right, keep that in mind. All right, so I want to go a little bit further before we talk about digitalization or smart factory, because this is where the basis is automation. Automation comes in industrial revolution, the second industrial revolution, right? No, the third industrial revolution, right, which was 100 years ago, right? So it's been there a long time, right? Without that, there'll be no smart factory that we have today, right? So let's understand what automation is. Automation is just, okay, if you have a process, input plus process, you have input, you do your process, your value adding job, and then you produce output to your customer, right? If you add 10 processes, let's say, then it becomes a system, it becomes your factory, right? But the basic process always would have input, a process, and output. So what is automation? It's just a feedback control. You could have feedback on your output, right? Feeding, and then you make decision on your process, or on your or and in your material also you could make a decision. Or if you want to go proactive, why do you want to check your output? It's going to be too late, right? Why don't you check your process? Because you have your process control, right? You could put your sensors on your process and also on the incoming material to make decision and to intervene or to act on the previous steps of your process or your supply chain, right? So this is automation, okay? Letting the system to run by itself based on feedbacks. Okay, so that is the basis of all the technology and artificial intelligence, you name it, machine learning or whatever thing that we want to talk about, right? It's all in the automated process. Okay, then if we want, this cannot be done without digitalizing it, right? Okay, there is a very clear difference from digitizing and digitalization, right? So you need to understand that digitizing is just, get rid of your analog data, right? Making it digitized, right? You scan into, make it a software. When you now I mean soft copy, right? When you want to digitalize those data, or those soft copy needs to be able to be manipulated, not just being read by your system, but data will have to be used and consumed and analyzed for your system to be able to take actions on it. So digitize is the lowest level of action that you want to do. The next step is for you to digitalize. Once you digitalize, then you need to consider for automation all this consideration. What kind of data do you want, right? What kind of volume of data do you want? Is it every millisecond, right? What kind of data storage would you have? So all of the things that I list in that box, you need to make sure that you know what you're gonna get. Okay. Okay. All right. um okay, so we talk about digitization, we talk about digitalization, sorry. um and now with IR 4.0, the key difference is now we are adding connectivity to it, right? Before this, if I have 100 machines, I could automate that 100 machines individually, right? They are not going to be talking to each other, right? They could talk to each other, but I have to connect them with a physical cable, right? Right? But now connectivity, what it means is that I could connect no matter how many machines that I have without the physical cable. All will go through Wi-Fi, okay, or any other gateway to the internet that we could use. So what I'm trying to show here is the convergence of the technology to give us what we could use today, right, in order to build our smart factory. So let's talk about this convergence, Internet of Things, right? Edge, I mean, edge is part of cloud, all right? So it's cloud computing. So now we have edge computing to make sure that we don't bombard our cloud so with so much data, right? Then we have artificial intelligence and of course big data. Okay, so if you look at this slide, what you have on your production floor is devices. You would have devices, you have equipment, let's say, and machines, right? And on these machines you need some form of sensor, right? Because say you want to get data of temperature, pressure, or vibration, right? Any other thing, ultrasonic power, let's say, or whatever you name it, you will get it. But you need to get the right sensor, and a lot of, I'm talking about machines that is not IoT ready. If they are IoT ready, you don't have to worry about this, because IoT ready machines now, they come with all the things that you don't have to worry. Their sensors are there, actuators are there. They have maybe edge already on that machine to make decision autonomously for that machine, right? And to be ready to be connected to other machines, right? So those IoT hardware must be I mean, they are level zero on your production floor, right? But as we go along on these slides, you would see that even if you have all machines that is not IoT ready, there are people who could retrofit it and make it IoT ready just by a simple integration into the system. Okay, so if you want to do that, you need to put, you know, those sensors, actuators, whatever thing on your machines and devices, and connect it with some protocol to the internet. All right. So even either if you are IoT ready or not, you need to connect. Then you need to use a gateway, right? Our gateway, what we are doing now is, I think we are using maybe HTTP, right? The common gateway to internet. But for a smart factory, it must be MQTT. Okay, the mosquito. It's a protocol that could go, that could take data continuously, you know, within milliseconds. All right, unlike HTTPS, it is very good in terms of linking documents, but not data. So MQTT, the mosquito, would be the gateway that we need to use. All right. Then you would connect this to the broker. All right. You need a broker. Why? Because imagine if you have a few machines. You know, sometimes even the same brand machines would be using different protocols in terms of communication. So this broker would take care of it. Okay. And I guess this broker, the we'll find out later. The key to this brokerage is the unique namespace that they automatically assign to every or any of your equipment, to make sure that it's accessible by all other systems that's connected to it. Okay, then there would be your analytics or event processing. Then there would be application where you could do some reporting to somewhere else, externally or internally, right? So that's how the IoT levels would look like. And if you add um, the computing power to it, like cloud, nowadays cloud is being hosted everywhere, right? And um, in recent years, edge computing becomes very popular, because why? People are trying to reduce the amount of data that being processed in the cloud, right? So they have edge. Edge is like just a mini cloud, but you put it on your production floor on individual machine. You could have your edge, or maybe a few edge on the production floor to get the machines to communicate or to be connected with each other, right? And then from this edge, things could be pushed to the cloud. Okay, all right. Um, okay, so now we talk about that process, and remember that we talk about the factory, the activity levels before. All right. So this is how it's supposed to look like, okay, in a smart factory. All right. Um, if you remember on the previous slides, okay, which I copy again on this slide, you have your at the highest level, start from your ERP, from the business planning, then it goes down to the manufacturing operations management with your MES, right? Then it goes down to the level where you are running the operation. Then you have your SCADA, you have your human machine interface, HMI, right? You have your PLC running to make decisions on and to react timely, right? In real time, but you see the problem with a regular factory is that a lot of times if you go into any factory, you see ERP, right? They might have MES, they might have SCADA, they might have HMI, but the problem is these things do not communicate with each other directly. Why? Because they might be using different protocols. The way they communicate, this manufacturer might be using a different language or a different protocol, right? So they cannot communicate to each other. So end up human like you and me or engineers would have to go around, okay, from ERP. If you look at the previous slide that I put there, right, in blue, right? If I have an equipment on the production floor, right, connected to my PLC, say if I want to get data from that machine, okay, that one machine, say I have one machine out of 50, I want to get that data. Then if I want to get that data in the ERP, then my ERP might be referring it with this name, right? Machine number one, let's say. If I go to MES will identify that machine with a different name, right? So I have to go individually and then collect all this data, and then so that they could talk to each other and manually feed. So it becomes highly manual. So that's not what we want. All right. That's the age before the IoT, right? So what we want is for all of your systems in these different levels, ERP, your MES, your SCADA, your PLC, they are talking to each other, and the key solution is in the IoT, right? The Industrial Internet of Things, by way of having your your mosquito, right? Your mosquito MQTT with its brokering all this interaction between all these levels, right? So in this system, you know what, it disrupt the whole the way we do things, right? um, in the current setup, if you are not on IoT yet, say if I want to improve if I'm an engineer, right? I want to improve my production, I add a new machine, let's say, right? Even if I use ERP, even if I have good ERP or an MES and SCADA, what I need to do is I have to connect this new machine individually to everything, right? To ERP, okay, with this name or whatever, right? Blah, blah, because they are talking differently. But with the IoT, with MQTT and its broker, I just plug and play, right? It would automatically, um, once we define the namespace, right? It would automatically identify our new machine as a node, as a node within the system, right? So it's brokering. Say if my ERP want to get data from this new machine, it's just gonna go into the MQTT and say, okay, identify this as a node 101, right? And it's gonna take that information and move it up to the cloud where it is in the ERP, right? So everything around it, everything would have a unique namespace and it's standardized in the factory. Okay, and that is very important because it would cut a lot of cost and a lot of work when you add or when you improve your quality. Okay, so this is what we want to happen. So usually in a smart factory, it would look like this. Okay, you have your equipment, all right, then you have your sensors or actuators to intervene, right? Everything will be connected to your PLC. You could use anything under the sun. I usually use Allen Bradley, all right. So then your PLC will be connected to your gateway. Okay, so from this gateway, and this is one stop connection to everything. Your human machine interface, HMI, is connected to this gateway, right? And then it's connected to your edge on any machine or and on your production floor. It's connected to your SCADA, connected to your MES, and also connected to your ERP, right? So think about it. If you are from factory, you would have maybe warehouse management system. All right, warehouse management system is just managing the inventory in your warehouse. How many parts do I have in which rack? Okay, if I want to ship today 100,000 parts, where do I find it? First in, first out, those kind of things, right? FIFO, right? So your warehouse management system also would be connected to your gateway, right? And the name of everything, your product, from which machine it comes from, those are unique and you don't have to worry about it. You just set the convention when you set up your IoT, and everything will just plug and play basically, right? And later we will talk about maintenance. So in this, your maintenance might be up there in the highest level, right? Or that CMMS, let's say, right, computerized monitoring and maintenance system, it would exist, transcends that level, right? It would be in the MES maybe, and it would be looking at your machines and then say, okay, these machines needs to be maintained, spare parts. The system would order the parts from the supplier and open up a work order for the technician to go and down the machine. It would schedule, so everything will be done, and this system would be also connected to your gateway, right? It would be running by itself. All right. Okay. So in terms, okay, so you know what a smart factory looks like. Okay. So quickly, okay, when you talk about quality, okay, the quality management of it. Quality is just looking at data. Okay, there are two parts of quality, right? Quality assurance and quality control, right? Assurance, mostly we do, upstream. Okay, when we do quality planning, okay, this is the assurance to do this and blah blah blah. Right? Control is on the production floor where we take samples and making sure that we follow or we comply to our own process, to our own specification, and of course to the customer requirements, right? So if you look at what things could do, where, all right, the edge computing, this is where a lot of decisions, a lot of real-time actions would be going on because they are right there on the production floor. Nowadays, I see edge computing people put right on the machine itself. So your machine will take data, will decide by itself, okay, I'm managing this machine. And then there would be a edge computing, say one edge computing and connecting like 100 machines that would be talking to each other, looking at this data, right? So what kind of computing power or what kind of activity, quality activity could you do on edge computing, and what kind of quality activity could you do on cloud computing? Remember, edge is there in between your production action and also the more um, uh, batched analysis that you want to do, right? So meaning that it is reducing the amount of data that you push to cloud, because it would be expensive for you to push everything to cloud. Expensive, and it's gonna maybe limit your bandwidth of pushing your data to cloud. So edge will have to filter, your edge will have to do certain things, right, in real time without bombarding everything to the cloud. Before the edge computing, everything would have been done in cloud, right? So edge is only in the picture a few years back where people see the need to have something in between. So things like looking at your statistical process charts, let's say SPC, right? Your edge can do that, right? And take actions on the out of control points, right? Or any of the out of control conditions, it would take actions. Either you design it to give warning, or you design it to stop your machine, or if you design it to automatically fix things for you in terms of your actuator could be automatically, increasing the ultrasonic power, let's say, or decreasing some gap, or these kind of actions could be done autonomously on the edge. Okay, I just put a quick a list there. Things that you could do. You could do GR&R, let's say, gauge repeatability and reproducibility when you want to do it, right? To look at how good your measurement is, right? This needs to be done, right? You look at a lot of other things, in terms of quality analysis. You could run some level of inferential statistics, right? Um, and hypothesis testing also on the edge, right? You could run your sampling plan and change accordingly, based on situation and your quality level, right? So these could be done on the edge. And on the cloud, you just keep it light and only would be pushing data for more strategic analysis. Okay, now you are dealing with big data. Imagine your machines are churning out data every milliseconds, right? So it could be really huge. So some of the data you analyze on edge, and some data that you need for reporting, for decisions at the highest level, or just look at your trend, right? And get into your population data, you would have to filter out which one you want. And things that you could do on the cloud, things like yeah, of course, you would have again some, you could run inferential statistics, analytics. You could put your artificial intelligence there to tell you what to do and when to do it, right? Your outgoing quality level, the decisions and the analysis of it could be coming from this level. Okay, so once you're on cloud, the you would be using big data technology, right? Things are in a GPU now, like billions of data, and a trillion maybe, right? So this slide is just to I'm listing down what kind of quality management that you could do where, right? Okay, let's look about this. Okay, so what um, in another form of it's more visual now. Okay, so what we are doing, what we could be doing, this is just the same thing as the previous slide. All right, what we could do on the edge computing and what we could do on the cloud computing, things like SPC, let's say, and things like the Yamazumi analysis, right? Chart. If you want to balance your line, say if you have a lot of lines, right? Before, these engineers like you and me would go in and say, okay, I need to balance, I need to run a study on how to balance my line from line number 1 to line number 10, so that I could have a very smooth flowing production. I minimize my rejects. I would minimize waste and those kind of things, right? But now if you use edge and put your appropriate programming, or teach your AI to do it, it would make that decision by itself. All right. And now, smart factories now have their production modules movable now, right, by themselves. If this module needs to go there, it's going to go and move and to the other line to help that line, or vice versa, right? So these are just another way of visualizing what you could do on cloud computing and on edge computing. On cloud computing, I remember when I was younger, I ran a lot of DOEs, design of experiments. It took months to do it, and I could only go to some data. But imagine with IoT, with artificial intelligence, and with a big data, what I did in 6 months, I think this system could do maybe in 5 minutes, right? With all this data, do I need to run experiment? If I do, then they would be running the experiments for you. Okay, which machine, at what setup, how many factorial do you want to go? How many level? How many factorial? Just imagine the power of it. It's amazing. I wish that I did not have to go through what I did go through when I was a young engineer, because now everything just teach the machine to do it. At your artificial intelligence with the deep learning, machine learning will figure it out, learn, and kind of decide themselves. Okay, I need to run this DOE. I need to use response surface methods, let's say, or whatever things that you want to do in DOEs, right? On or in any other quality tools that you want, right? My point is this: if you wanna set your smart factory, you need to include your quality engineers in. Why? Because they would know what data to look at, how to analyze, and what kind of actions we need to take if this data comes out, right? Technologies that could run IoT or could write AI or machine learning or data scientists would not be able to tell you that, right? So you need to work together. A quality engineer will have to work together with all these people, data scientists, system integrators, and whatnot. Okay. Okay, we have so little time, so I'm just going to go quickly. Okay, so let's touch. Basically, we are about done with the smart factory. I just want to touch about the pain points of maintenance. A few years ago, I was doing some studies with an operation offshore, right, to look at how much data do we need in order to have a productive maintenance of the equipment there, right? And it took a lot of data. Okay, there were like for the 2 years study that we did, right, we had 8.6 billion rows of data, and this is on, I think, on only a couple of machines. Okay, not even not too many machines, right? And the data size is not so bad, 350 gig, but okay, that's only on one machine. So what I'm saying is that we are running out of time. What I'm saying is that in order technology could run your CMMS for you, right? They could sense when your machine could break down. They could predict, given the right sensor, right? Again, you have to work with the experts in this and with the quality people also, right? Talk about reliability of machines and whatnot. You could use your digital twins. Nowadays, some companies offer you with digital twins, right, to kind of predict your machine. So all of this, right? The once you get connected and digitalized with your artificial intelligence and things like that, or your CMMS will be taken to the next level. They would know, the system would know which machine to be down, what, when. Okay, if you want to go down this time, then you will connect to your production planning. Say, okay, production planning will have to maybe reduce or increase whatever thing, right? Then it would talk. It would maybe send PO to your supplier, buy the spare parts in advance, right? And then a plan for the technicians to be in at what time, and then maybe on the safety side would be maybe requesting the permit to work, those kind of things. So everything is actually running in the background by the system. It is such a it's amazing. Okay, I want to talk a little bit about MOC. I'm rushing because it looks like too much information to share. MOC, right? A lot of time in my experience, problem happens when we did not manage our change. It could be a simple change, but the impact is crazy, right? So nowadays with technology, with IoT, right, artificial intelligence, right, we could connect our MOC to oh Hang. I think we are on Q&A already. Um, but anyway, um, okay.
Hey, no worries, no
So
worries.
again,
You
I'm
just
just gonna
let
go.
us know. Right?
Yeah. Very quickly. So again, the MOC, right? Enough for me to say that there are a lot of software and applications out there that could really connect your MOC. It's not going to be. I remember when I was a young engineer, right? To run one small change took me about sometimes 4 to 6 months just to get the approval, because why? We have to run experiments, we have to do this because we were so worried about MOC. But imagine if everything is connected, right? Things will take care of itself. It might cut that governance just to ensure the same quality, the same safety with connectivity and digitalization. It might cut 4 months worth of work maybe to only a few days, right? So that's the power of connectivity in MOC. All right. So looking back, okay, what could happen in a smart factory is this: we could really stretch the way we manage quality. I talk about quality planning before you even start your production, right? Once you start your production, then your quality management, your quality control, and the activity in quality would happen, right? So in terms of looking at stretching, what I'm saying, it is not an error there. I really stretch that picture to show that, hey, we could really stretch our quality management with technology. And what we are doing is actually the same thing that engineers have been doing all along. If you want to reduce your reject rate, let's say, right, you monitor, you look at data, what are the reject and what are the rejects, what are the defects, and then I run improvement, right? Then I go to a new improved state, right? Or if I want to improve my capability, right? CPK and on my machines and process, and I need that data, and then I run improvement, and then I would be at the new state. This would be continually, it will be continual, right? Once I get to that new level, I would need data to make it better, right? So what I'm saying is that all this is being done by the system. By connecting our machines, we don't need to have, technicians running experiments, getting data. And even if we have human getting the data, we might miss a lot of data because human cannot handle that huge data. All right. um, this is just to show that, hey, everything could be connected, and we could even check our compliance to say for safety, the DOSH requirements, everything could be checked and audited by our artificial intelligence, right? The NLP. If you read the news in 2020, I think one of OpenAI, right? One of Elon Musk company, the GPT-3, this artificial intelligence, the database is in the trillions. So you could imagine that a machine out there could give you any literature you want. If I say, okay, I want to check, I want to run audit, am I complying to, say, ISO 45001 or any other DOSH regulation, FMA, let's say, Factory and Machinery Act, right? Or even OSHA Act, right? What usually traditionally your safety and health officer would be running audits, look at your own documents, practices, right, and check. It could take at least what, 50 man hours to do that, right? But now with artificial intelligence, it could be done within seconds. Okay, so you could audit your compliance every day if you want to. Of course, usually we do it once a year, right? So these are the things, and of course, it's connected to everything under the sun in your factory. Okay, so quickly before I leave you, if you decide to embrace the technology, the things that you need to do is the key ingredients are these three factors. Okay, your people, your process, and the technology that you want to use. All right, because if you look at it, if you have good people, you give process to your good people, you scale up. If your good people could produce 10 pieces a day, you give them a good process, they might be able to produce 100, right? And if you give your people technology, They would innovate. They would find ways to do new things. You give your beef up your process with technology, you would automate, right? So if all these factors come together, you would win. Okay, I don't have time, so I have to go. So consider this. All right, consider. Sorry, if you go out, I went out to eat and I was surprised that some mama stalls and quite a lot of joints now are using robots to serve us, right? So just just think about it. These are restaurants, and they are not even factories. They're not like in the millions or multi-million dollars kind of establishment, and they invest in technology. Why do they invest, you think? One of the pain points is managing people, right? This what you call it, ADR, autonomous delivery robot. These things run on 50 watts of power, right? They weigh 58 kg. They could move at almost 1 meter per second. uh, and they could work 15 hours non-stop on a single charge of 4 hours. All right, imagine they don't take leave, they don't talk back to you, they don't sulk, they don't take long breaks. All right, easy to manage, and they are consistent, right? So this is the technology, and even Mama Store use them now. So what is stopping you as a factory to go and jump and use IR 4.0, right? So again, I would leave you with, okay, if you really want to go into this, look at your people, process, and technology, and you could run your own assessment, or you could get the experts to do it. But these are the things that you need to look at, right? Integration, your integration philosophy, your facility, your enterprise. So those are the dimensions, right? The trust and dimensions that you need to look out for if you want to go in on this journey to become a smart factory. So I'm sorry I took maybe 5 minutes more than what we planned, but thank you for having this tea talk with me.
No worries, sir. Right. I believe the informations are very fruitful to all of us lah, to expose us in some of your expertise areas, right? Yeah. So actually, just now that you mentioned the robot who brings the deliver the food to the customer, this and that, I actually came across to a few shops right in KL. They actually did that, you know. Yeah.
Mm,
So I was quite shocked, like even the mama stock, and they invested in stuff like that. All
yes.
right. So before we call it a day, right? So just a quick question, lah. Huh? So what is the expected next phase of the industrial revolution?
Okay, people have been talking about the fifth industrial revolution. I think I
Yeah.
heard about that talk, I think even as early as 2019.
Mm-hmm.
To tell you the truth, right? So what what people are talking about, okay, you remember, this industrial revolution must be adopted or must be agreed by the technical experts, right?
Mm-hmm.
By the
Yeah.
industry, right? So after years of technology, back in 2011, they were having, I think, I can't remember what the name of that meeting was in Germany, and everybody agree, okay, this is the time of industrial revolution 4.0, right? So in 2011, this, okay, everything adopt that term, industrial IR 4.0. R 5.0, the next one, is not officially here yet, but we heard about it this past year. So meaning that it's not officially here. So the next phase is going to be, okay, remember, if you look at the way we progress, Hang, um,
Mm-hmm.
um, the fourth industrial revolution is just putting what automation, whatever thing, and we are connecting everything, right? Everything could be connected to the internet, right? And then comes other disruptive technology that support this connectivity.
Mm-hmm.
We haven't really talked about advanced materials, right? Augmented reality, right? Those are really exciting, that could really converge and disrupt a lot of things that we did. Okay, so if you
Mm-hmm.
talk about IR 5.0, it is actually trying to me, right? Industrial Revolution 5.0 is just to make sure that human could really work with this technology, right? Not so
Mm.
much in introducing, okay, I want to introduce a new, we talk about metaverse,
Yeah.
Okay, that would be definitely the next one. But the thing is, okay, now we have cobots. Now we have artificial intelligence working, right? So the next revolution would be where does that put the human, right? We
Mm.
have to be very careful in terms of developing, in terms of executing or applying this technology on the shop floor. The next revolution would be how human would interact or would work. The technology of human and cobots, let's say, or robots or
Mhm.
artificial intelligence working together. That is the next revolution, right? Because now there is no clear approach or no clear governance on, hey, how should we work together, or should we replace? If I have 100
Mhm.
operators on my line, I just replace all 100 with, say, 50 machines, right? That's what we could do now. But the next revolution would be, okay, how do we make sure that human and these robots or artificial intelligence could work together, right?
Mhm.
And that would also include the metaverse. Metaverse, you just imagine, yeah, you could be in the factory without being in the factory, right?
Yeah.
I just,
Yes.
yeah, log on and say, okay, oh, I'm in the factory, I'm here now, oh, you are there. All right, so we just go in with our avatar, right, and do the
Yeah.
job in the factory
Yes.
in metaverse, right? So I
So
think, yeah,
basically, in short, I think the IR5 is not yet officially introduced by government, but
no,
most likely it will be something like enhancement of the IR4 and also the coexistence between the AI and also the human resources, lah, right?
yes, 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 that's
All
what it's
right,
gonna
thank you, sir. So, if you guys have any question, you guys can feel free to drop it in the comment. We will reply to you in these few days' time, right? Since the questions are not here up in the live session, right? So no worries. And also the YouTube actually video will be out in our channel if you guys want to revisit the content again. So in the comment section, we actually will put up the feedback form for all of you to give us more suggestion in the next topics and so on. Yeah. So right. So thank you, sir, for a wonderful morning and also informative sharing today. And we hope to see you guys again. All right. Thank you so
okay.
much.
Thank you, guys. Okay, bye bye. Have a good
Bye
day.
bye. You too.
Bye.